Hello there my dear students, welcome to my channel. Okay, in this video I'm going to explain to you about a chemistry paper 6, and this is a 42 October-November 2020. The duration for this paper is 1 hour. Okay, let us move to the first question. Okay, number 1, the diagram shows the apparatus used to pass an electric current through a concentrated hydrochloric acid. Okay, hydrogen and chlorine were formed at the electrodes. Okay, so before we go through this question, so let us explain about this one. So the ion present in this solution is a hydrogen, chlorine, and also the water. Okay, so the positive, the cation will go through the cathode. Okay, this is the cathode, and here is where we have the anode. So anode is a positive charge, so it will pull chlorine and also hydroxide. So both of these will go to anode and this one will go to cathode. Okay, since it is a concentrated, so it will be choosing chlorine. Okay, so we will have a chlorine ion there. So they'll move to anode to get discharged to form a chlorine atom, and due to their properties, which they will appear as a Dewey atom, group 17, so they'll appear as 2. So here we have a chlorine gas. Okay, however, at the cathode, here we have a hydrogen. They'll accept one electron and they form hydrogen. Okay, due to their instability, they'll form a hydrogen. So here we will have a hydrogen gas. Okay, now we go through the questions one by one. Name the item of the apparatus labeled A. Okay, they are asking for this one. This one is beaker. Okay, we move to the next one. So here they are asking the electrodes were made of platinum. Okay, normally they'll be using a carbon or platinum as the electrode. Okay, give 2 reasons why platinum is suitable material for the electrodes. So you can say number 1, because it is inert. They don't mix up with the electrolyte. Okay, because it is inert. Okay, secondly, they are good conductor of electricity. Okay, this is 1 mark, this is 2 marks. Okay, suggest another material suitable to use as a electrode in this experiment. As I explained to you just now, we also can use carbon rods. Okay, so this is another 1 more mark. Okay, now we move on with the next one. Okay, the teacher doing this experiment wore safety glasses. Okay, they have gloves for acid, and had their hair tied back and stood up the experiment. State one other safety precaution that would be taken when doing the experiment. Explain your answer. This is a safety precaution and also explanation. Okay, so here safety gloves. Okay, if you notice that this experiment, it is releasing chlorine gas. Okay, chlorine gas. So for if you inhale a direct chlorine gas, it is quite toxic for us. So the best thing here we can use is a fume hood, or we call it as a fume cupboard. Okay, this is to suck up this chlorine gas when it is released during this experiment. Okay, so because the chlorine gas is very toxic, so it need to be absorbed as fast as possible. Alright, so this is your 2 marks. So total we have here about 6 marks. Now let us move on with the next question. Okay, number 2, a student investigate the rate of reaction between sodium metabisulfate and a potassium iodide. In the reaction, starch was used as an indicator. At first, the reacting mixture remained colorless, but then suddenly changed to a blue-black color. So the basic concept of this experiment is the basic understanding when we have a iodine, okay, when we have a iodine, so this one will be when it is in contact with starch. So what happens is it will change the color into a blue-black color. Okay, now 5 experiments were done. In each experiment, the total volume of liquid was 45 centimeter cube. Okay, how they do the experiment 1? Using a 10 centimeter cube measuring cylinder, 5 centimeter cube of aqueous sodium metabisulfate was poured into beaker. Using another 10 centimeter cube measuring cylinder, 5 centimeter cube of aqueous starch was poured into the beaker. So here's a 5 centimeter, here's another 5. Okay, using a 25 centimeter cube measuring cylinder, 15 centimeter cube of distilled water was poured into the beaker. There's another 15, so it's just reaching about 25. Using another 25 centimeter cube measuring cylinder, 20 centimeter cube of aqueous potassium iodide was poured into the beaker. So here's the final 20. So all we have is a 45, which is stated over here. Total volume of the liquid was 45. Okay, now at the same time a stop clock was started. Okay, once the potassium iodide was poured in, stop clock has been started. Okay, the mixture in the beaker was stirred until a sudden color change was seen, which is the blue-black color. The stop clock was immediately stopped and the time is recorded. The beaker was rinsed with water. Okay, and then as we can see here, the experiment 1 was repeated by using 17 centimeter cube of distilled water and 18 centimeter cube of aqueous potassium iodide. So they are only changing this distilled water's volume, which is here, distilled water's volume, and also the potassium iodide's volume. However, both of these remain the same, which is 5, 5. Sodium metabisulfate is 5, starch is 5. Okay, let us go through. So here we have 17, 21, 23, 25. And here's 10, 12, 14, and 18 here. Okay, now let us look at the question. Okay, A. Use the information in the description of the experiment and stop clock diagrams to complete the table. Record the time in seconds. Okay, so in seconds. Okay, now here volume of aqueous sodium metabisulfate, volume of a distilled water. Okay, here is the aqueous potassium iodide. Here's 20. Okay, now let us look back at the previous page. Here's 20. Okay, if you notice that the volume for aqueous sodium metabisulfate is always 5. Okay, so always a 5 centimeter cube. And there is no changes over here. So what we can do, we can place it as a 5, 5, and so on. And then the volume of a distilled water, here there is some changes. So here we can put as it is 20. Your distilled water here will be 50. Okay, so we fill up the 15 here first. So here will be the 15. The next one, here will be 17, 21, 23. So 17, let me scroll up first. This is number 3, 4, 5. So here will be 5, 5, 5, 21. What is after 21? So it's 23 and 25. So it's 23 and 25. Okay, now let us record the timing. So here is 30. Okay, this part is 30 and here is about 45. So here will be 35, 40. So here, let me make a bigger picture. Okay, so here will be 35, 36, 37 and 38. So here will be about 38. So scroll a little bit down. Okay, so here will be the same, 35, 40. So 41 and 42. Okay, over here we have 6, 7, 8, 9. Okay, this is 50 and this is about 55 and here is about 53 seconds. Okay, now we have the minutes reading. Okay, it's 1 minute, so it's 60 seconds and plus with 1, so it's 61 seconds. Now here we have 1 minute, so it's 60 seconds. So here will be 5, 10 and 15. So the reading here is a 12. So 60 plus with 12, you'll be getting here about 72 seconds. Okay, so it's time to make it smaller. Okay, so I hope you can get all the readings correct. 5, okay. So all these, the marks to complete this table is 5 marks here. Okay, let us look at the question. Next question. Okay, now here B. Plot the results from experiment 1 to 5 on the grid. Draw a smooth curve of a best fit. Okay, here they are asking for time to change the color, the timing, and versus volume of aqueous potassium iodide. So which is volume of potassium iodide, which the time and the volume of potassium iodide, which means they are asking us to plot this and this one. Okay, so these are the two columns that we need to be focusing on. Okay, so I'm going to screenshot this and apply to the next slide. So here I'm going to crop this picture. Okay, copy, and I'm going to paste it over here. So we will be referring to this data to plot. Okay, now is the time to plot. Okay, now we look at the first one here. Okay, let me label this one down. Okay, this is the time taken and this is the volume. Okay, so first one is 20 and 38. The time is 38. So the time is 38 and volume is 20. The time is 38. So let me make it bigger. Okay, so it's 38. So it's 1, 2, 3, 4, 5, 6, 7, 8. So here is 38 and 20 will be here. So roughly we can plot it over here, this part. So I can plot here x. Okay, the next one here will be 1842. So here is 18. This line is 18 and 42 is here. So 42 is here. So 42, 18. So it will be here at this point. Okay, the next one here will be 1453. So is 14 here, this point, and 53 which is here. So roughly is here 1453. Okay, the next one is 12. Next one is 1262. 12 and 61. 12 and 61. So 12 and 61. So 12 and 61 is here. 12. So this is 1261. The last one here will be the 10 and 72. So we plot this 10 and 72. 10 and 72. So 10 will be exactly at the y-axis. 72. So it's roughly here. So we can plot this carefully. So here will be exactly 40. Okay, now they ask us to draw the smooth curve of best fit. Okay, so this is the smooth curve that I've managed to draw with my pen tablet. So I hope you can draw much more better than this. Okay, now for this one, see, okay, from your graph, predict the time to change color if 16 centimeter cube of aqueous potassium iodide, which is here, show clearly on the grid how you work out your answer. Okay, they're asking us to show the time, right? So what we can do here, we just draw the line, a straight line, which will be showing exactly over here. Okay, so if you look at it, the graph is showing here. So which means it is 40, 2, 3, 4, 5, 3, 4, 5, 6. So it's about 46. Okay, so it's about 46 seconds. Okay, now the next question here will be calculate the volume of distilled water required if 16 centimeter cube of aqueous potassium iodide was used. So we look back at the question at the beginning. Okay, here back at the table. Okay, if you notice that both of these, when they added distilled water and potassium iodide, they ended up getting 35 all total. Okay, 35, 35, 35. If they are using a 16 here, 16, and here should be 19. Okay, 16, 19. So that's how we can get a 35. So okay, so here will be 19 centimeter cube. Okay, now sketch on the grid the graph you would expect if experiment 1 to 5 were repeated to a higher temperature. So the hint here, if it's a higher temperature, your rate of reaction, you'll have a faster rate of reaction, right? Faster rate of reaction. So what happens? Now we look back at our curve here. So it should be, when every reaction must be faster, your graph should be, you have to draw your graph slightly lower. Maybe we can start from here and here. So we can draw, but not touching the curve line, okay? So just draw, just follow the curve. Yeah, it should be like this. Okay, so this is for higher temperature. Okay, I hope you can understand here. This one. Now look back at the next question. So over here, we need to calculate. Okay, the concentration of potassium iodide in the reaction mixture in each experiment can be calculated by using the equation shown. Okay, this is a volume. So calculate the concentration of potassium iodide in the reaction mixture in experiment number 2. So look at number 2, experiment number 2 here. Is they are using 18 centimeter cube of aqueous potassium iodide. So it's 18 here. Okay, 18. Now, okay, we just have to substitute here 18. So let us see how much we are getting. 18 divided by 45. So I'm getting here 0.02. Okay, mole dimetric cube. Okay. Now state which experiment 1, 2, 3, 4, 5 had the fastest rate of reaction. Fastest rate of reaction. So we can look here. We need to look at the time as well. Okay. These are the time taken. Time taken here. Okay. So now this is a much more lesser distilled water. So if the concentration of the solution is much more concentrated, and it takes about only 38 seconds. So this is the fastest. Okay, now we look back at the question here. So we can put the experiment number 1. They ask us to state. So we just follow the question. 1 mark here given. Okay. Suggest why the volume of distilled water added to each experiment was increased as the volume of aqueous potassium iodide was decreased. Let me increase the, okay. Distilled water added. Okay, the answer for this question, you can get it from directly from the question actually. So which is over here. Look at this part. So the solution here, how to answer this question is, the total volume of the liquid was 45. So for all the experiments is only 45. So even though they change the volume of aqueous potassium iodide, they need to adjust with the distilled water. Alright. So here is to keep the volume constantly at the 45. So that is your answer. Okay, here G, give one change you could make to the apparatus used, which would improve the results. Explain your answer. Change to the apparatus and also the explanation. Okay, now let us go back at their procedures. Okay, now if you notice that, okay, let me erase all this. Okay, if you notice this, they are measuring 10 centimeter cube with a measuring cylinder, which is not that accurate. So normally for a very small volume, we need to use pipette or burette. Okay, so this is the changes that we can make. So this is my suggestion here. So let us look at the question and answer this. Okay, we can use a pipette, use a pipette. Okay, there are explanation here to get more accurate volume. okay, volume of solution to obtain accurate results. Okay, sorry for my bad handwriting. Okay, now here, how could the reliability of the results of this investigation be checked? Okay, to verify this, so what we can do it over here is, we can repeat. Okay, we can repeat the entire experiment and we can compare. You can say that repeat and compare the results. Okay, this is 1 mark. So total marks for this question number 2 is 18 marks. So now let us move on with the next question. Okay, number 3. Solid Q and solid R were analyzed. Q was a zinc carbonate. Okay, so zinc carbonate. We will have a carbonate. It can produce carbon dioxide. Okay, now test on solid Q. Complete the expected observation. Solid Q was placed in a boiling tube. Okay, and a zinc carbonate, remember, it cannot be dissolved in water. Okay, so here's a 10 centimeter cube of sulfuric acid was added to the boiling tube. Any gases produced were tested. So the content of the boiling tube were kept for C. Okay, kept for C. I think better we can write here the equations. Okay, so here will be zinc carbonate plus with the sulfuric acid. So what we can get over here, we will get here zinc sulfate, carbon dioxide, and also water. So I don't simplify this. So we have a carbon dioxide and a zinc sulfate. So they're asking the first observation here. So what you can notice, so zinc sulfate. So this is much more is a soluble. Okay, this is a soluble. Okay, please remember that all sulfate salt are soluble except for plumbum. Okay, plumbum sulfate, mercury, and also barium. Okay, so these three, they are not soluble. Okay, now so here the observation, so you can see here is 3 marks. So we need 3 observations over here. So one is, you can see there's the bubbles. Bubble appears. Okay, bubble form. Okay, bubble formed, and then solid. Okay, solid means this one, right? Okay, this zinc carbonate is a solid. Solid precipitate, dissolve, and you can also say so the bubble form is a carbon dioxide, and they also included any gas producers was tested. So here will be lime water turns milky. Okay, identify the gas given off in A. So it's a carbon dioxide. You can write it. So we got here 3 marks and 1 marks. So now for the C, they mentioned the content of the boiling tube were kept for C. So which means it's a zinc sulfate. Okay, now we go through this question. Okay, the reaction mixture from A was filtered. The filtrate, which is this, okay, the zinc sulfate, was solution S. 1 centimeter depth of a solution S was poured into boiling tube. Okay, now they are asking the aqueous solution, sodium hydroxide was added dropwise and then in excess to solution S in the boiling tube. Okay, now they are asking for the observation. So first is at dropwise and then is in excess. Okay, now let us look at the short notes that I've prepared for you. Okay, so here is the metal, the cations. Okay, this is the effect of a sodium hydroxide. Okay, now this is aluminium, ammonium, calcium. So we have all these cations. So zinc will be at last. So you can see here, this one is only for. Okay, now we look at here this part. So the zinc, we have a white precipitate. This is for the dropwise, and then it dissolves in excess to form a colorless solution. Okay, so guys, please remember this. Okay, go back to the question. So we can have a white precipitate, can then dissolve in excess. Dissolve in excess sodium hydroxide to form colorless solution. Okay, this is 2 marks. And then okay, we look at the next one. Okay, explain why is it not possible to identify the cation contained in solution S from your observation in C1. Okay, so if you notice here, the white precipitate for the dropwise and then dissolve in excess sodium hydroxide. So now let us look back at here the notes, the short notes. Okay, so white precipitate for sodium hydroxide, we will have zinc, and we have okay, white precipitate. Okay, we will have calcium. It also we have a white precipitate for dropwise, and it is insoluble, so this is not relevant. So we look at aluminium over here. Okay, we look at aluminium. So it forms a white precipitate and dissolve in excess sodium hydroxide to form a colorless solution. So aluminium and zinc, they share same results. So that's why we cannot identify which one is it. So you can also say aluminium produce the same results. Okay, aluminium produce the same results. Okay, now number 3. Suggest an additional test that can be done on solution S to confirm the cation was a zinc 2 positive, the zinc ion. So the only solution here is to add excess ammonia solution. Okay, is to add ammonia solution. You can see add excess ammonia solution. Okay, why is excess ammonia? Is because if you look at here, okay, this is for, okay, this row is for the ammonia solution. Now here we have a white precipitate for aluminium, and it remains insoluble in excess. So we can scroll down for zinc. Okay, look at the zinc. So the zinc will have a white precipitate and it dissolve in excess. So only zinc will be dissolved in both. Okay, only zinc will dissolve in both sodium hydroxide excess and also ammonia excess. So please remember this one, guys. Alright, so we have done this. Okay, now let us look at the next question. Okay, for the test on solid R, tests were done and following observations were made. Okay, now we have a flame test over here. Okay, a flame test was done on solid R. Okay, this is they produce a yellow flame. So let us look back at the short notes. Okay, now here, group 1, group 2 metal ion flame test. Okay, so only cation they will have a flame test. So if you have a red, is a lithium. If it's a yellow, is sodium. Lilac is some kind of purple color, so it's potassium. Red brick flame is a calcium. So we want here, we want this yellow flame, so it's a sodium. You know, we go back to the question. So this is a sodium ion. Okay, now solid R is dissolved in distilled water to produce solution R. Okay, the solution was divided into two equal portions in the two test tubes. So we have managed to get the cation for this, and now we need to get the anion. So the test 2, 1 centimeter cube of a dilute nitric acid followed by a few drops of aqueous silver nitrate were added to the first portion. Okay, so this is normally for chlorine, bromine and iodine. Okay, so now let us look at the color that they form. So you see here, this is for anion. Add the nitric acid plus with the silver nitrate. If you look at these two solution combination, it must be either chloride, bromide and iodide. So white precipitate for chloride, cream precipitate is for bromide, and yellow precipitate is for the iodide. Okay, so guys, please remember this one. This chart is very important. Okay, now, so for our case over here, we need to be focused at the iodide. Okay, because it forms yellow precipitate. Now we go back to the question. Okay, this one is confirmed is a iodide. Okay, second portion of solution R was added to 1 centimeter cube of aqueous bromine. Solution changed color from orange to brown. Okay, this is due to when you have iodide and bromide. So the bromine is much more reactive compared to this iodide. So what happens is you will have a displacement reaction there. So you will have iodide here. So you can say since the displacement reaction is taking place, so it's confirmed it is a iodine. So now identify solid R. So solid R, we will have cation as sodium positive and iron as iodide. So your solid here is sodium iodide. Okay, so here's the 2 marks. So total marks for this question is 10 marks. Okay, now let us look at the next question. Okay, number 4. Brass is the mixture of two metals, copper and zinc. Okay, copper does not react with dilute sulfuric acid, but zinc react with a hot dilute sulfuric acid to form soluble salt zinc sulfate. Okay, plan an investigation to find the percentage by mass of zinc in a sample of brass. So in your answer, you should include how to calculate the percentage by mass of zinc. You have access to normal laboratory apparatus. So the marks given here is normal 6 marks. Okay, this is for every question for paper 6. Okay, now here this is my suggestion answer. Okay, first we weigh the brush by using weigh balance or anything that any measurements that you can weigh the brush and record it as V1 W1, and then we add the excess sulfuric acid and heat it up, so that this is my explanation. So all the zinc can react with the acid and form a soluble salt. So now all the zincs will become soluble and leaving the copper as a solid. So now we filter it and collect the residue, which is the copper, and wash it with water to remove the remaining zinc salt. Alright, okay, then and here we try the residue and weigh it again and record it as a W2. Alright, so now we have to minus this to find the percentage of a copper first. So first we minus W1 minus with W2 to get the percentage of the copper divided with the initial weight. Then multiply with 100, you are getting the percentage of the copper. Okay, the copper's percentage. Now to get the percentage of zinc, what we can do, this is 100%. Okay, the weight of the brass is the 100%. So 100% minus with the percentage of the copper, we are getting a percentage of the zinc. Okay, so if you answer all this, the keywords, you'll be getting a 6 marks. So if you have a excess time during exam, you can draw like this. So this is how the experiment will look like. Okay, so okay guys, so all the best for your exam. So if you have any question, please comment below. So I hope I can help you guys throughout my video here. So all the best, wish you luck, and don't forget to subscribe and like this video. Thank you very much guys. All the best again.